everybody. Thank you all for coming. It's an honor to have you all here. Today we're going to discuss the restoration process. So we're going to give you guys a quick tutorial on how to identify concrete repairs in your building, some of the magnitude of repairs that may occur. Some other aspects of concrete restoration involve expansion joints, waterproofing. All these items we're gonna get into momentarily. I'd like to introduce you my father. For all of you who don't know, this is Marty Levi. He started this business.
Guys, enjoy the lunch.
He's our CEO. He started this company 30 years ago. So we give him a lot of credit. This is George Perez. He's our senior project manager. He's an architect, majored in architecture at University of Miami. He is an expert when it comes to expansion joints, waterproofing, so he'll be speaking quite a bit. We have Cesar Menendez coming in. This is Buster Cash. He's been with us for many years, second father to me. He specializes in sales as well as project management as well. Cesar is our in-house paint expert. He worked for Benjamin Moore. He should be in here any moment. He worked for Benjamin Moore for about 15 years, so he is an expert with all different types of coatings, which we will be discussing when it comes to your buildings as well. This is Kevin. He's in charge of marketing and he's our IT director, so he'll be just taking some pictures and filming if you guys don't mind. If you guys are camera shy, just let him know and he'll be sure to leave you guys out. Okay?
He'll blur out your picture.
That's right. He won't put you on the website. So
has everybody signed in?
Yeah, if everyone signs in, it's important so that way we can get your certificates printed out. So again, we'll feel free to interrupt anytime, ask questions. Feel free to get up, use the restroom anytime. Make yourselves at home. Feel free to eat as much as you can. We got a lot of food, so I want everybody to really have the good experience here. All right, so some of the things we're going to talk about is obviously concrete restoration. Why is this not sinking? There we go. All right, so we're going to be discussing obviously concrete restoration. We're going to get into the different type of concrete repairs, how to identify concrete repairs, areas that are structural and not structural. I apologize. I need to introduce you guys Sinisha. He is with Falcon Engineering. I apologize. He's our guest. He's gonna also give us a few words after to give you guys an idea on the expert process when you actually hire a owner representative or a structural engineer to assist in this project in concrete restoration. So I apologize, Sinisha. And that's Cesar. Finally, he made it with us again. Cesar, our paint in-house expert. So. Concrete restoration, we're going to discuss the different
repairs. Real quick and let everybody
introduce
their name and their property.
Let's do it.
I think that's always a great idea.
We'll start over here.
Well, my name is John Fernandez. I'm with Mystic Point 100. I've been with Casa Group for about 3 years now.
Okay, go ahead.
Matt Lebeff, at Lauderdale 1.
I'm Jose. I manage the Alta Marina Loss in Aventura.
I'm Vic, I'm with the Waverly also.
Joey, Wilson Station.
Carrie, I'm at Paragon Plantation.
I'm Antoinette, and I'm at Brenda Plantation.
I'm Chloe, I'm at the Symphony Condominium building.
Renee, I'm at La Club International.
And my name is Michael, I'm at the Beach Club.
Okay.
And here we have Mabel from
Atrium at Aventura.
Perfect time.
It's okay.
Justin,
Come sit up.
some lunch.
Yeah, we have some extra chairs here.
Yeah.
And then maybe we'll just get her the sign-in sheet as well. So I'll continue. So yeah, we're going to get into concrete restoration, obviously. Different types of repairs. We'll get into the details, how to identify what is concrete restoration. We'll discuss about post-tension cables. Does your building have post-tension cables? What are they? The different type of post-tension cable repairs. How to identify these repairs. We're going to discuss stucco repairs. There are different types of stucco repairs. Waterproofing, expansion joints, railings. Of course, a lot of these water intrusions are caused by railings. How to maintain the rails. If you're going to, if you have an older building and you want to modernize it, what type of rails you should recommend to your client. Different types of finishes, paint. So we'll get into that. Shutters. We will discuss, everybody believes that shutters, a lot of residents are so worried about their shutters. But a lot of the times the shutters create a lot of the problems, so we'll get into that as well, and of course, we'll discuss paint as well. You know, paint not only serves as an aesthetic portion on the job, it's also a weatherproofing, so we'll discuss that. So concrete restoration. Within concrete restoration, you have different aspects of the job. Some of the items we're going to discuss specifically in concrete restoration is the pre-existing condition surveys. You know, why is this important? What is a pre-existing construction survey? How to survey repair areas, how to identify the repairs, shoring and installation of the shoring, demolition. We're going to discuss cleaning and coating of the reinforcements in the slabs and in the concrete. And we're also going to discuss forming and pouring of the concrete as well as stucco. So pre-existing construction surveys. So when you perform a pre-construction survey, we recommend that you document the existing conditions on a building. So if we were going to mobilize on a job, the first thing we would do on a balcony is we would take pre-existing surveys, videos, pictures of deficient tile, cracks in the slab, pitted glass, deficiencies in the rail. When we actually take on a job, we walk the residents out, we take full responsibility. So any damages that may occur to these balconies, it's always going to be blamed on the contractor. So what we do is we compile extensive pre-existing condition surveys, we create a database. If there's a structural engineer and owner's representative, we give them a copy of it. We actually encourage them to do the pre-existing survey with us as well with a representative from the management. Sometimes they don't have a representative, so after we do this pre-existing condition survey, we give you guys a copy. Sometimes we create it on a USB or a website we create, any type of database, however way that you guys feel is necessary, but it is extremely important. There are always residents in condos that just point the finger at the contractor. It's inevitable, and it happens on every single one of our projects. So
Easier.
it's easier,
for
exactly.
the
And you know,
others too, so.
yeah, residents are always looking to just say, hey, it could be even tenants, hey, you know, my glass on my rails is pitted, it needs to be replaced. My window is scratches, it needs to be replaced. So as long as everything gets documented, there's no way that someone can point the finger at the contractor. It helps protect the association and the contractor. So it's something that we recommend, and it is industry standard. Survey of repair areas. So a lot of times a condo will hire an engineer. The first thing the engineer will do is he'll propose to them and say, we can evaluate the entire structure. We'll hang out swing stages on your building. Sometimes they ask the contractor to provide the swing stages, and they literally sound tap your entire building and look for delaminated and hollow areas. A lot of times some of these repairs are obvious. You can see rust spots, you can see cracks on the edges, but a lot of times we recommend that the more extensive evaluation an engineer does, the better it is you can let your association know of the magnitude of the repairs for budget purposes.
Can you address how the property manager should respond to the board that says, you know what, we really don't want to spend the extra money for an engineer?
Right. So, so technically, it is a requirement to have a structural engineer. The city requires you to have a special inspector, they call it. So the city cannot be there to evaluate every single repair you're doing for your building. So they require a structural engineer who is technically represented for the city, who is compiling engineer reports, and who is involved in every aspect of the restoration process. So if your association is saying, well, we don't want to have a structural engineer, but they want to go ahead and do a 40-year recertification or a 50-year, or they want to do concrete repairs, it is a mandate. They have to have it. It's part of the Florida Building Code. So you can limit the amount of hours an engineer can be put on the job. A lot of times condo associations hire a third-party owner representative, a consultant who comes in, manages the job, and he's the mediator between the engineer, the contractor, and the management and the association. So it is critical to have an engineer on your job. Now, engineers survey buildings differently. Because of budget constraints, an engineer may say, we'll do 30 units, we'll do a spot check. And then they collectively come together with a percentage of what they feel the deterioration on the building is, and they come up with a bid package. it's never 100% accurate. No one has x-ray vision. No one can actually see the magnitude of the repairs till you actually go in and open up the job. A lot of times we take on jobs, engineers, they assess and they say you have a certain amount of repairs on the job, and it's not even there. It doesn't even come to 50% of it. Those allowances are given back to the association. So at the end of the day, it's an educated guess. Unless you actually, even if you actually survey the entire building, every single square foot, every single square inch of concrete, it is still an educated guess because you don't really know what's underneath. A lot of the issues you have as well is with tile. When you're doing the acoustic sounding, a lot of times there's proper in-tile installation or a lack of thin set or mortar. Everything seems hollow and delaminated. It could be that you're taking up residence tile and there's no delamination underneath. So again, it is a gamble, and you deal with a lot of angry residents. But it is the board's fiduciary responsibility to make those decisions. Sometimes it lacks waterproofing underneath, so you want to take that opportunity to go ahead and waterproof all the slabs. At the same time, you're removing their tile to be proactive, which we'll discuss when we get into the waterproofing portions of it. So surveying the repair areas is very important for budgetary reasons, as well as to assess the actual repair areas needed. Shoring. Shoring is very important as well. When you're doing concrete repairs, the structural integrity gets compromised while you're actually doing these repairs. So it's very important that shoring gets placed. A lot of times engineers require shop drawings, shoring plans to get created which is the contractor's responsibility. You would submit those shoring plans to the structural engineer and have him approve them before you actually commence the work. This is very necessary. This is a part of the building code, and this is just industry standard to make sure you have the necessary shoring in place. A lot of times on the balconies, it's easy to place the shoring because you're closing out the entire balcony, so residents don't have access to that area. Sometimes you have to shore 3-4 balconies at a time, depending on the size of the structural repair.
Has everybody signed in? Okay, I just want to make sure.
A lot of times garage shoring becomes an issue because of parking. So if we're working in an area and you have a column repair, you can see we've taken up about 6 or 7 spots to put the necessary shoring in place. So logistics is key when it comes to shoring. We encourage having weekly meetings on site, sometimes bi-weekly meetings depending on the availability of the association and the management. To discuss these issues. If we know we have a large area in a garage in place, we like to give you a week to 10-day notice to get these cars out of the way. If you have a valet area, if you have valet that needs to be involved in the coordination, it's very important. But shoring is a necessity. Sometimes you have shoring in place for 30, 45 days while the concrete is curing. All depends on what your shoring engineer and structural engineer mandate on the job. These.
If I may just interject here, coming from a position of an engineer, the shoring is, all of you are involved with this from a management position, and finance is the main focus of how to keep the project under budget. Shoring is 99% of the time additional cost that nobody can account for a simple reason. We don't know where and when is shoring going to be required, and we don't know how extensive that shoring is going to be. And why do we need a separate engineer for shoring? Most of the time shoring is considered a specialty engineering, and it cannot be done by any licensed engineer. There are specialty engineers that are specified for shoring only. So those two things together make it most of the time an additional cost. And you pick up the grief of the board and everybody else. How come nobody knew about this shoring beforehand? And mind you, shoring can be very, very expensive. If what Yaniv is showing here, 6 spots going three floors down, imagine this is happening inside somebody's unit. These column repairs can happen on penthouse level or any other level, and we need to shore 3 floors down in people's units. It can be very expensive, very intrusive. Luckily, we don't have these situations a lot. Mostly it's confined to the balconies and garages. But just so you have a perspective on the shoring, when it's required, it's most often an additional cost, and it becomes a big issue, inconvenience-wise, financial-wise, and sometimes time delay wise.
Tanisha, let me ask a question. Sometimes I'm asked, why can't the engineer retained by the client do the shoreline engineering as well? Why can't the same engineer on the job that identified the problems that need to be repaired, why can't he do the shoreline? Why can't they do it?
Again, it's a matter whether that engineer is specialized in shoring or not. If the engineer is, technically the same engineer could do the same work. However, most of the time it's a niche business and there are specialty shoring engineers that's all they do, just shoring. So most of the time, regular engineering offices don't have a shoring engineer on staff. They just go outsource it, give it to a third party, and they design it for everybody else.
There are 3 or 4 guys in the industry right now that we talk to on a regular basis when we need specialty shoring. And usually around PT cable issues, those are more complex. You know, so there's even less people qualified to understand the language of PT shoring and stuff like that.
So, once you have all the precondition surveys in place, you're mobilized, you survey the repair areas, you know exactly what areas you're going to begin, you have demolition process. Now, there's different types of demolition. Normally, obviously this is means and methods of the contractor, depending on the parameters you're working off of. If it's a swing stage and you're working on a balcony, you use a chipping hammer. Sometimes if you're working on the deck or in a garage, you have the luxury of using, you know, heavy machinery which can help with the demolition. So the issue comes to demolition is the sound travels off the reinforcement. Your building vibrates, there's nothing you can do. You may be having a building, 385 units, you're going to divide the building into 4 phases. You're only working on phase 1 of 4. Phase 4, which is on the other side of the building, will definitely feel the vibrations. There's absolutely no way getting around it. We've had clients ask us to use smaller machinery, which is a possibility, but you know it does take longer. We've even had clients ask us to use a hammer and chisel, believe it or not.
Yeah.
But it is an absolute necessity to use this type of machinery to break apart the concrete. When we're going to get in a moment into different types of concrete repairs, you have partial depth, full depth repair. So you'll get into the magnitude. But demolition, the main purpose of the demo is you have to use the chipping hammers, and there's really no way of getting around it.
The Flintstones didn't build the high rises, right?
That's right.
Chisel and a hammer.
That's right. That's right. So we get into repair methods. There are several different types of repair methods. You have a partial depth repair, you have a full depth repair, edge repair, you have crack repairs. Some cracks are structural repairs, some cracks are not. A lot of times they're just aesthetic. You have beam and column repairs as well, and then you have windowsill repairs. We're going to go ahead and get into each one of these repairs right now. So partial depth repair. Partial depth repairs are very shallow surface repairs to those that extend as deep as one top of the as deep as the top of 1/2 of the slab. Normally these repairs are about 3 inches thick. If you have a 8-inch slab and you have a concrete repair and it's a partial depth repair, you would go normally about 3 inches deep till you can see the underlayer rebar and see what the conditions are. A lot of the times you have a partial depth repair, the engineer comes out and he says it needs to be a full depth repair. These type of things are out of our control. The structural engineer is the one who makes these decisions. Obviously everything gets documented in as-built and engineer reports, but a lot of the times this does occur. So this is one of the examples where an engineer will estimate that you have 300 square feet of partial depth repairs on the job, but those 300 square feet could very well end up being full depth repairs, which is about 25% more in cost. Full depth repairs. Full depth repairs are, you know, pretty obvious. It's when you have to, if you have a 6 or an 8-inch slab and you're going all the way through, both levels of rebar are completely deteriorated, and it needs to be the concrete needs to be completely removed, and reinforcement needs to be cleaned in place. A lot of the times, you know, if we have a large area that we know needs to be full depth repair, our guys will start to speed things up. We'll just start to demolition. Once they start seeing that they have some clean rebar, with the engineer's approval, he will say stop, this is enough, and then they will start doing the cutoffs on the section so they can have a clear cut for when they pour the concrete. we'll discuss that momentarily as well. Edge repairs. Edge repairs are very common. In industry standard, edge repairs are usually 8 to 12 inches back. So if you know you have an edge repair, engineer comes where an edge is where the railing is sitting on, and you see some deterioration, he'll mark that area. Depending on what your contract states, you're immediately just going to cut 8 inches to 12 inches back, and you're going to demolish that entire edge completely. You're going to go full depth. So this is a very common practice in the industry, and most engineers recommend that you do full depth repairs on the edges as well.
Top right corner, what are we looking at over there?
This
Yeah.
this is the edge of a balcony. You can see if you look down, that's the tennis courts. So this is an example of we actually replaced the rails in the building. So the first thing we did was remove the rails. We knew that there was going to be significant edge damage. A lot of times also when you replace new rails, engineers recommend that you replace all the edges as well, so you have a nice new strong concrete. But this was an example of reinforcements that needed to be added to hold the new glass rail. So we went ahead, we chipped back 12 inches on all the edges in the building, we added the necessary reinforcements, and then we form and we pour it in place.
If you see right over here, this little block out that's there laid out, that's where the rating is going to be, the rating post. So why do edge repairs fail often, is because if the balcony is sloped so that the water can drain, this is the weakest area because all the water is going to go towards that edge. And you have conditions of potential water intrusion just by natural design. Wherever you have a rating post, you need to have really good grout, and you need to have the grout that's a little higher than the concrete so that it wouldn't sit there. So these are avenues that water comes in and tends to fail edges. Other conditions why edges fail is because you have a lot of rebar in the edges to keep that slab tight together. All that rebar, all that water that's coming shedding in front of it, they tend to cause spalling a lot faster than the regular rebar in the slab that you saw in partial and full depth repairs. Everything we've seen so far has been conventional reinforcing. That's regular old building design. Some new buildings still have that. We'll get to the PT section, which a lot of newer buildings have PTs, and we'll talk about that. But this is basically the leading edge of your balconies. Okay, and that's the edge, the entire edge. Okay.
Just for your information, cutting 8 to 12 inches is only possible on conventionally reinforced buildings, which means buildings without PT cables. Buildings that do have PT cables, it is impossible to cut and do the repairs on the edges the way they are described here. This only exclusively pertains to regular reinforcement on the buildings.
Just for everybody's knowledge, what is the typical cutoff in year of construction between conventional and post-tension? Is there?
Not necessarily. And
Yeah.
if you look at that building over there, that picture of right behind where the table is with the food, those are 7 buildings that are just completed now, and that's conventional steel.
Okay.
For example,
So is it size of the building?
it's a type of construction. The difference between conventionally reinforced building and building with post-tension cables is that post-tension cables allow much larger spans, the distances between the columns, and much thinner slabs. If you would want to have a span between 2 columns of, let's say, 30 feet in conventionally reinforced building, the slab would be very, very thick. And the developers obviously don't want to pay for that. So let's find a better solution. The better solution was installing a PT cable. So if the layout of the columns and support system, the frame of the building, structural frame of the building allows, you can do conventional reinforcement on any building. For example, one of the bigger buildings, newer buildings, Regalia, just at the end of Sunny Isles Beach, that building that has that's a conventionally reinforced building. It's a building that is 3 years old, and only 2 levels of the garage are post-tension cables because they needed bigger spans for the garage and parking space and all that. But the rest of the building, because of its very regular shape, is regular conventional reinforcement. But the speed of construction, the savings in the thickness of the slab, all PT slabs on standard buildings are 8 inches. And the columns can be 30 foot apart. So that allows for interior decorators, architects, a lot of play, a lot of room, so they can do interior design the way they like.
And another pro to PT cables, and we'll get to it, is that because they're protected with a sheathing, they wouldn't allow to get rust that easy. They're greased, they have caps, so one of the benefits of that is, plus the ones that were mentioned, is that it's very difficult for it to corrode because it's protected within itself. Okay? We'll get to the PT soon. Crack repairs. So crack repairs, like we mentioned earlier, there's different types of cracks. There's structural cracks, there's dynamic, there's movement cracks. So it needs to be evaluated. Can it be fixed just by opening it up, chasing it, and putting caulking over, and then maybe waterproofing or something like that? Some cracks can, but some cracks travel through the slab and they need to be epoxy. Why would you want to fix a crack? Why wouldn't you just want to chip it? Because you can maybe salvage the concrete, you can salvage that bond by putting an epoxy in there. So it'll bond the whole thing. Things will break around it before that epoxy fails. But maybe you don't need to do epoxy. Maybe you can just put caulking and it'll bridge it and won't allow more water to come in through that crack to cause more problems. Okay? So there's the basic groove. You chip it out, you do a run through it, you put the sealant in there or epoxy. Epoxy injections. So you can see here, this is what kind of looks like. It's going to be like a yellowish, and it's going to be hard like glass, like a really very impossible to remove. You can't cut it, you can't chip it. It's a big process. But
high viscosities. Yeah, some epoxies can be up to 12,000 psi. Normally concrete is an average of 5,000, 6,000 psi, but epoxy is very, very strong. You know, it all really depends on what the structural engineer recommends, but a lot of the times, you know, aesthetically they're not the most pleasing. We've had a project in a garage where it wasn't structural repairs. They were having structural cracks. They were having a lot of leaks. So we went ahead and I'll show you. We went ahead and used a polyurethane injection all along the slab. It looked like spiderweb cracks. So the client came to us and said, "Wow, this looks horrible. This is not what we wanted." But you know, we solved the issue with the leaks coming down into the garage below. So we recommended putting a vehicular waterproofing, which is something we'll discuss as well. So keep in mind, you know, if you have actual cracks, whether it's epoxy or polyurethane injection on your slabs in your garage or balconies, aesthetically it's not the most pleasing, but it is not an aesthetic repair. It is a concrete repair. Okay, so epoxy injection is structural. Polyurethane is usually for non-structural cracks.
Can you apply a coating on that to paint it, say if it's a garage, for instance?
You can, yeah. So we'll get into a vehicular coatings you can apply over it. Sometimes there are certain waterproofing systems that actually bridge cracks depending on the thickness of the crack, which we'll get into as well.
Can you stucco over it if you wanted and then paint? Cracks?
Well, these are more injections on slabs, but yeah, there are crack repairs in stucco that we will get into. So you have beam and column repairs as well. So this is where the shoring gets extremely necessary. Obviously, column and beams, they're structural elements, they're load-bearing elements. So how you attack these are very critical, and they are very important to have your structural engineer involved with the inspections. A lot of times on column repairs, they're partial repairs. Sometimes you have to remove the entire column. All depends on the deterioration and the reinforcements in the column and on the beams. But it is very important to have the adequate shoring in place because, again, you're compromising the structural integrity. These are actually, for the most part, holding up your structure. So if you compromise these areas, you could actually do even more repairs, even more damage on other areas of the building, which will begin to crack and the concrete will deteriorate. So it's very important that shoring is placed correctly in these areas. Beam and column repairs also can take place on balconies. Not only does it take place in garages, but when you actually see major concrete column and beam repairs, a lot of the times we see it in garages and and in basement areas.
There's a very simple reason for that, I'm sorry to interrupt you. Columns are vertical load-bearing elements, and simple. The biggest weight of the building is at the bottom, and that's where you're gonna expect to see the most damages, if anything, because all the floor is gonna stack up at the bottom of that column, which is usually in the garage, and that's where the biggest loads on that column are, and most water from underground and whatnot, moisture. So those two things combined are gonna lead to the damage of the column.
Those
A
are my
lot of the
questions.
columns are interior, so they're not exposed to the elements.
But the load works without the environment as well. So, and especially when we talk about the garages, most of them are open and exposed to some of the damages. The interior columns are very rare to have damage, and when the interior columns do have damage, and even on higher floors, it's usually indicative of some kind of other problem, not necessarily just wear and tear or things like that.
Another type of concrete repair are windowsill repairs, very common as well. It's when you're actually repairing the concrete around the window so you can have the correct seal where the window sits on. We find a lot of these water intrusions coming into the units on some of these buildings. I'd say 60% of the time is from the actual sill coming through the concrete. A lot of times it has to do with caulking. Sometimes you have the stucco to metal. Caulking is deteriorated, water's shooting through that, or a lot of times you have glazing, which is glass to metal. The condo that I live in, just from Hurricane Irma, they had such high winds with rain, and a ton of water was seeping in through the glass to metal caulking. So that's something very important that you always have an eye out. A lot of times before we pressure wash, we ask management to send a memo out to the residents of that line if they've had leaks in the past, to let us know now. We can do water tests. We literally just shoot water onto different areas of the window to see where the water's coming in from. So it's one of the ways to be proactive to actually find leaks. Sliding glass doors, a lot of the times it's very similar as well. Sometimes you have the water coming underneath the sliding glass door track. A lot of times it's just a gasket that needs to get replaced on the sliding glass door. But these are some of the things that need to get maintained every few years. We recommend about every 7 to 10 years to do a miscellaneous concrete restoration and paint job. A lot of times window repairs and sealants are left out of the scopes of work. We recommend that at least water tests get done while you have your guys while you have the company pressure cleaning the drops for the paint. It takes no time. Most companies wouldn't even charge extra money for that. But it's something that needs to get coordinated. So.
Is it possible to do a water test without a swing stage?
It is. It depends if you have a fixed window on a balcony and you can access the balcony. But a lot of times is the logistics of getting the hose. Not every balcony has access to be able to put a water spigot to connect the hose, or if you can run it down from the roof. But the easiest way would be from a swing stage. So, okay, cleaning and coating reinforcement rebar. So once you had your different types of repairs, either if it's partial depth, full depth, edge repairs, coating of the steel is extremely important. You want to use a corrosion inhibitor. There are different kinds of corrosion inhibitors. You have to get it approved by your structural engineer first. There's actually corrosion inhibitors you can paint on the rebar right before you do the concrete pour. When you clean the rebar, you want to clean as much rust and the delamination that's on there. So you can either wire wheel, which is you use a 7.5-inch grinder or a 3.5-inch grinder, which has these metal brushes. It's like one of those metal brushes, which is not highly recommended by engineers. It's usually done for smaller repairs. For example, like this little edge repair here. But most of the time we use sandblasting. And on the next slide I'll show you a video of the sandblasting. But once you actually have the reinforcement clean, it's evaluated by an engineer. If he tells you that you're able to go ahead and pour, you would add this corrosion inhibitor on the steel, which is a protective coating for the steel. A lot of times in the concrete, you'll have a big concrete pour. They will include the corrosion inhibitor inside the mix code of the mix, so of the concrete. So it's really up to the engineer how he wants to handle the corrosion inhibitor. This is a video of actual sandblasting that takes place. It's a little bit blurry, but you can see that it's, you have to have a protective suit on. It's a silica sand. It eliminates a lot of dust. It is very tedious, and it does make a mess. But unfortunately, most engineers require it, and there's no way of getting around it. Sometimes you have to do these type of sandblasting on actual balconies, 30 stories in the air, and the sand just goes everywhere. That's why it's very important that the contractor takes, the necessary precautions. If there's windows around, you need to board up the windows or put film, protect all areas, because it will hit the glass. Last but not least is forming and pouring concrete. Obviously, you want to have a compressive strength, a minimum of 5,000 psi. There are different types of concrete pours. You can use a bag mix for small areas. You would actually, many different manufacturers and suppliers have different types of concrete mixes. You will need to submit to the engineer first and get their approval. A lot of the times, though, when you have large concrete repairs, big areas, you'd want to pump it. It's faster, it's more affordable for the contractor, and it's less of a mess for the residents. But it is, a logistical nightmare. Sometimes when you are shooting 30, 40 feet in the air, you need to coordinate it. You have to close down certain areas of the building. You're going to be having hoses run up the building, so sometimes these hoses need to get anchored onto the building. So we always encourage to do concrete pours with concrete chunks and concrete pumps if it's a big enough area. So it does make the job go a lot faster, but sometimes you have smaller repairs and you actually need to physically mix the concrete with the water on site for these little miscellaneous repair areas. Okay, we'll get into stucco. You want to just talk a little bit about the stucco, or Caesar?
Can I get into the stucco with the paint, because it kind of all will go hand in hand?
Sure.
That's actually one of Castle's job.
That's
Sterling. That's right.
Sterling.
Ah,
How long ago was that?
This was about
6 years ago.
5 years
3.5,
ago.
4.
Yeah, this was a very large stucco work, but they had a tremendous amount of developer defects on this job. We'll get into the stucco repairs we had to do on this project, but they had four, industry standard. You never apply stucco that thick, so we had to remove, I'd say 70% of the stucco on the building, add reinforcement, but Caesar will get right into that for you now. So we have two different types of stucco repairs.
I want to work kind of backwards from paint to stucco, because the stucco is affected by the outer layer, and paint has a function.
You want to start with the paint?
Yeah, just real quick. Yeah, we can even. Okay, paint nowadays, well, let me give you all just a basic understanding of what paint is. Paint is what covers the building and protects the stucco that's behind it. Now, what differs paint from a commercial 7-year warranty paint, a 10-year warranty paint, and now manufacturers are actually coming out with a 15-year warranty paint. Paint is, the easiest way to break it down is if you have a gallon of paint, and paint is consistent of volume solids. Volume solids is what stays behind and dries and gives a thickness to protect the stucco. Now, when you buy a gallon of paint, a 7-year commercial paint, volume solids is going to be anywhere between 28–34%. So that means that 62 or 72 to 66% of what you're holding in liquid is going to evaporate into the atmosphere. So what you pay $40 for, you're actually getting the 28 to 34% is what stays behind on the wall. Now, when you go into the 10-year paints, now you're getting into thicker, higher solids, and there's reasons for that. Waterproofing, water repellency, the better the paint, the higher the quality, the more volume solids. A higher grade paint is going to be anywhere from 44 to 52% solids. So you're getting a good film thickness that's going to stay behind to protect your stucco. That's pretty much the best functional understand paint. Now, when you go thicker on a higher quality paint, what's important to also realize is what's called a perm ratio. Perm ratio is how fast the water will evaporate through that paint if it gets behind it. The thinner the paint, the higher the perm ratio. The sun will hit it, water gets behind it through a windowsill. Before it actually starts to build a bubble and collect water, it'll evaporate out through the paint. The higher the solids, the lower the perm. So you'll see on specifications by engineers written out where on the shear walls, they're putting the high quality 10-year, 12-year, 15-year thick paint to protect that shear wall. But on your balcony ceilings, you're gonna have a lower grade paint. It's still gonna apply with the same warranty, reason being, it's not getting hit directly with rain. The sun is not affecting it at all. So it'll have that lifespan. But they wanna make sure if water comes through that balcony, through that top, makes it to that balcony ceiling below, it'll have time to evaporate out before it creates a bubble and delaminates. That's pretty much how paint works, and you'll see that every manufacturer has their own specifics to their best lines, their commercial lines, Sherwin-Williams, Benjamin Moore, Stowe, and whatever company you're using to paint your building, or your engineer wants on your building. Now, when we have the paint hit its lifespan, a lot of us see paint that say lifetime warranty. Lifetime warranty is the life of the paint, not your life. I sold paint for many years, and I had people come back and tell me, "Yeah, I only painted it, 12 years ago. Why is it falling apart?" Well, did you read the small print? The life of the paint is 10 years, and that's it. And these manufacturers manufacture pretty much to the T. If you have a 7-year or 8-year paint, it's time to paint. Once that paint loses its viscosity, let's say the 8-year paint started at 34% solids. 8 years later, it's actually gonna be at 28, 27. You'll start seeing chalky. When you touch the paint, you get that chalk in your hands. Now it's retaining water. Every time it rains, water's getting trapped into the paint, going straight to your stucco, going straight back to your wall, your block, and we'll start having delamination. An example is, I visited a building, a friend of mine was living there. They were at 7 years to paint. They were doing a new construction right across the street. The building looked pretty good, had very little chalk, not much. It would have been a straightforward paint job. The board decided to wait for 2 years for the building across the street to finish. They went from a regular paint job to, I'm gonna say, close to 4,000 square feet of stucco delamination on the building. And it was that time period. Water is now penetrating through the paint to the stucco, creating delamination. And with stucco, and this is what we all look at, is those hairline cracks, and then you walk up and you sound it and it sounds hollow. That develops pretty much throughout the years as the building is built, whether you get the best stucco is anywhere between 5/8 to 3/4 of an inch. Now buildings are going up so quick and not straight. So we're getting either 1/2 inch as far out as 3 inches, sometimes even more, of build out with nothing keeping that much weight of concrete or helping that weight stay on your wall. I was at a building yesterday that's a fairly new building. It's exactly 8 years old. They had, during the storm, about 80 square feet of stucco just fully delaminate, come straight down. And I was looking at the stucco on the ground, it was 1.5 inches. There's nothing keeping that weight there. And it's a very tall high rise, very difficult to swing, so it's gonna take a creative mind, whatever. But anyways, that's the point. Your buildings will sway with the wind. They vibrate when trucks come by. All the elements in the atmosphere, the wind, the rain, starts creating that vibration, which causes delaminating stucco as time goes by. And you also have a lot of developer defects, where they built out that stucco with no reinforcement. And one of the examples is the slide he had with the Sterling. The stucco had been built out up 2 inches, 2.5 inches.
Actually, it was some cases it's 3.5.
At 3.5.
Yeah.
There's nothing supporting it. The proper way is, you put a support at a point to where you build it out. You put a wire mesh, so all that stucco that's being added on will adhere.
So if you see in these pictures, you have two types of stucco repairs. You have a standard stucco repair and an extended stucco repair. So, so what you see here, what he's referring to is an extended stucco repair. This is a repair where the stucco is applied greater than 3 inches thick. A lot of times you can build it out with a mortar, or sometimes you have to actually install a fiber reinforcement mesh, which we did here at the Sterling. This was the case here, which gives actual reinforcement in the stucco, and it can hold buildups of stucco greater than 3 inches, 3/8 of an inch thick. So a lot of times these are common developer defects we see on a lot of newer buildings. Very common. Can become a very expensive repair. Average stucco repair would be industry standard $14. Sometimes for a repair like this, depending if it's either reinforcement or if it's a vertical mortar that you have to build it out with, it can be up to $35 a square foot. So there's a big difference in the pricing. It's a lot of work. It's pretty tedious, as you can see in the video.
What, from your experience, why do you think it's common from a developer to just cut back on material? Is that the reason why?
I think it's just lack of oversight, in my opinion. Also, a lot of times, you have a contractor who's building a wall, and you have some belling in the wall, and nothing's straight exactly. So they just add additional material in one area to make it look even. A lot of times, you don't have inspectors on new construction sites going up and inspecting every square foot of stucco being applied on the building. They look at it from the top, bottom, oh, it looks complete to me, and lack of quality control. So, that's my opinion. Also, we know there was a lot of corruption back in the day in different municipalities, so there was a lot of lack of oversight. But
a lot of that has to do with the required men to finish a job on a certain time. If not, they get liquidated damages. People start buying units and they want to move in. So they got to finish the job. There are tolerances that are within contractors. But let's say I'm the stucco guy. I come after the concrete is done. Okay? So I'm going to put stucco, but it exceeds my tolerances of how thick I should or shouldn't do it. So if I question it to the GC and I tell them, hey, listen, the shell guy got to fix the wall, and I can't stucco, they'll find another stucco guy to do it. So they intentionally know that this is getting done just for time sense, and they deal with the consequences of that later. I'm not saying that, put that in the Herald and put that in, now, but that is a common thing. The stucco guys put in a spot to make the walls plumb, look pretty, yet they kind of go over their limits, Especially on buildings that are not squared or rectangular, the ones that have the nice rounder shapes. The shell is typically not favorable for the stucco guys to have a nice look, so they tend to build out things a little more, and it happens quite often.
Thank you.
a lot of times, this would be just a standard stucco repair. They're applied in two coats. You have a scratch coat, and then you have the finish coat. And then on top of that, you apply the paint once the stucco is cured. And again, it's typically applied at 3/8 of an inch thick. This is just a standard $14 a square foot repair. This is the most common repair you see on a lot of your buildings. So now what we will get into is post-tension cables, George's favorite.